Good morning, children. This is class 10th physics, chapter 11, the human eye in the colorful world. Today we are going to cover the topic scattering of light. Right, scattering of light. Now, what do we mean by scattering? Scattering is, children, when the light it enters the atmosphere. When the sun's light enters the atmosphere, in the atmosphere, various particles are present. The particles may be dust particles, it may be the water vapor particles, it may be the molecules of gases like oxygen, nitrogen, carbon dioxide, etc. Yes, so these particles are present in the atmosphere. So when the sun's light it enters the atmosphere, it is absorbed by these particles, which are known as scatterers. So these particles, that is dust particles, the water droplets, the gas particles, they absorb the sun's light, and after absorbing, they re-emit it. That is, they again emit it. So this process is known as scattering of light. Right? So you can write it as when the sun's light enters the atmosphere, it is absorbed by the scatterers. Scatterers in bracket you can write the dust particles, the moisture, the gas particles, and then they are re-emitted in the atmosphere. This phenomena is called scattering of light. Right, children? Now, once the light has been scattered, its color depends upon the size of the scattering particles. As I told you, there are many scattering particles which are called scatterers, right? Present in the atmosphere. Suppose the particles are very small. They are very fine. So if they are very small, they are only going to scatter the light of shorter wavelength, that is blue color. Now children, we know that blue color light looks something like this, right? Its wavelength, that is length of one wave, is very small, or it is short as compared to red, and this is a red light. So this half, this is one complete wave. And here you can see, compare it with blue, the wavelength of blue is very small. So when in the atmosphere, the scatterers, the particles are of very small size, they are only able to scatter the blue color of the light. That is, they are only able to scatter the shorter wavelength light. Right? The medium particles present in the atmosphere, that is the scatterer, they are able to scatter mainly the longer wavelength light, that is the red color. Right? What does it do? It absorbs the red color, and after absorbing the red color, it re-emitted. Right? And the very large particles, the very large scatterer, what they can do? They can scatter all colors of the light, right? And finally, as all the colors of the light, starting from violet, indigo, blue, green, yellow, orange, and red, all are scattered. So finally, after scattering, the light will appear to be white, right? When only blue is scattered, the scattered light will appear to be blue, right? And when only red is scattered, the scattered light will appear to be reddish, right? And when all the colors are scattered, because the particle size is very, very large, then the light will appear to be white. So children, the color of the scattered light, finally after scattering, the light you will get, its color finally depends upon the size of the scatterer. It depends upon the size of the scattering particle. Right children? Very small will scatter blue color light. Medium size particles will scatter red color light. And large particles will scatter all colors light, and so finally the scattered light will appear to be white. I hope this is clear. So this is your scattering, and scattering is the phenomena in which the light is absorbed by the scattering particles, which you can call it as scatterer, and after absorbing they re-emit it in all the direction. This phenomena is called scattering of light. So based on this, there are many phenomena as well as we have used this. First use is the use of red light for danger signals. Children, you might have seen that wherever you need to put a danger sign, it is in red color, right? So why all the danger signs are in red color? Why the stop signal for the traffic light is red signal? Because children, as we know that red color has a longer wavelength, and red color light is not scattered by very small scatterers. They are scattered only by medium size scatterers, right? So red color light cannot be easily scattered, right children? Okay, so let's start with it. So we will start with the first point, that is about the wavelength of the red light is the longest in the visible light. This we know. The light of red color is scattered the least. It is scattered the minimum by the air molecules of the atmosphere. As its wavelength is longer, so it is scattered minimum by the air molecules which are present in the atmosphere. Hence, the red color light is able to travel a longer distance without getting scattered. Right? It will straight away travel a longer distance without getting scattered much. And so, as it is able to travel a longer distance without getting scattered much, it will be able to cover a long distance, and it will be visible from a far away distance as compared to any other color of the same intensity, right? So only children, the traffic signals, they are made red because red color light is visible from quite a long distance, because its wavelength is long, its wavelength is more, and as its wavelength is more, it is scattered the least by the air molecules of the atmosphere. And as it is scattered the least, it will cover a long distance and it becomes visible from a farthest distance as compared to any other color. Right? So children, this is the reason why red color is used for danger signals. Next phenomena is, why do the clouds appear white? Right? Why do the clouds appear white? Now, as we started with the scattering, I told you that the color of the scattered light, it depends upon the size of the particle. Right, children? If the size of the particle is very small, let me change this color. If the size of the particle is very small, then blue color light will be scattered. If the size of the particle is medium, then red color light would be scattered the most. And children, if the scatterer or scattering particle is very, very big, then we know that all the colors are scattered, and finally the scattered light is of white color, right? So clouds are white. So it means that in cloud, the scattering particles, the scatterers, they are of very big size. So only after scattering we are able to see white color. So let's see this one quickly. The clouds are near the earth surface. They are very near the earth surface, and they contain dust particles and very big size water molecules. As they are close to earth, the dust particles which are present in the cloud, they are also of bigger size, and the water molecules which are present in the cloud are also of bigger size as compared to the wavelength of the visible light. So children, here visible light, all light will come, VIBGYOR, your VIBGYOR. So the particle size, that is the water molecules and the dust particles which are present in the cloud, their size is bigger than the wavelength of all these colors, right? Now as the scatterer size is bigger, so all the colors of the Vibgyor will be scattered, right? All the colors would be scattered. So that is our next point. It says that as the dust particles and water molecules present in the cloud scatter all the colors. So they are scattering all the colors of the light from the sun. And hence, as all the colors are scattered, finally the scattered light that reaches our eyes is white, and so the clouds appear to be white. I hope this is clear. Let's move to the next point, and that is blue color of the sky. And that is, children, blue color of the sky. Now let's see why the color of the sky is blue, because clouds are appearing white but sky appears to be blue. Why does this happen? Now we know, children, that when the scatterer size is fine, means it is small, then the blue color light would be scattered the most. So this might be the reason, right, children? So let's see it. The upper layer of the atmosphere, right? We are talking about the high, right? The upper layer of the atmosphere, it is uh, it does not contain dust particles, as it is quite far from the earth, because the pollution will be less there, right, children? So dust particles will be less, and uh, the size of the particle, the scatterers, will be less, right? So gases, water vapor, whatever they are present in the upper layer of the atmosphere, that will be of very small particles. That will be of fine particles. So these fine particles, they are going to scatter only or mainly the blue color than any larger wavelength. So it will scatter only blue color light, right? And so the sky appears to be blue. And here they have compared about the wavelength of the red light to the wavelength of the blue light. That wavelength of red light is 1.8 times that of the blue light, right? So why does the sky appear to be blue? Because the upper layer of the atmosphere, it contains the dust particles and the gas particles which are of very fine or very small size, and these small size particles or these small size scatterers scatter mainly blue color light, that is the shorter wavelength light, and so the sky appears to be blue. Right, children? So this is explanation to this, the blue color of the sky. So mainly, children, it just depends upon the size of the scatterer, right? You have to keep your answer focused to the size of the scatterer. Now next, children, you will see that the sun, it appears to be reddish during the sunrise and the sunset, right? You might have observed this. So red color means, children, the scatterer size is medium. the scatter size would be medium, right children? So we are going to relate our answer to this. So let's see how. So children, during the sunset and during the sunrise, the sun will be very near to the horizon, right? Horizon we have done. Horizon is the line of sight. Horizon is the line of sight, means the line from which we are going to view the sun, right? हम जिस path पे, जिस site पे, जिस line से हमारी आंख sun को observe करेगी, that path, that line is your horizon, right? That line is the horizon. So what happens during the sunrise and the sunset? The sun is very close to the horizon. Horizon के बहुत पास में होता है. So as the sun is very close to horizon, the sunlight, it travels larger distance, right? It travels a longer distance. Okay, and as it travels a longer distance, we know children here that when the light is getting scattered and it has to travel a longer distance, blue is scattering, right? Then in Vibgyor, all the colors get scattered. But as it has to travel a longer distance, the blue color fades away, the violet color fades away, the indigo color slowly, when it reaches our eyes, it fades away. And finally, the light that reaches our eye is of the longer wavelength, that is red color, right? I will give you the explanation of this topic once more. I have prepared one more slide for that, and it's over here. So children, this is your NCERT content. Now be very attentive for this. Now light from the sun near the horizon passes through thicker layer of air and larger distance in earth atmosphere before it reaches our eyes. So when the children's sun is near the horizon, so we know near the horizon, so the layers of the earth, it would be optically denser, because near the earth it would be polluted, more dust particles, more gas particles, right? They are all cool, so they are dense, right? So it has to travel through very thick layers of air, and as it has to travel through very thick layers of air, it has to travel a larger distance, right? And as it has to travel the larger distance, so near the horizon, most of the blue light and the shorter wavelength light, they scatter away, and they are not able to reach our eyes. The only color that reaches our eyes is the longer wavelength, and so this gives the reddish color of the sun. But on the same side, when it is noon at 12 o'clock, when the sun is over our head, so at that time the sun has to travel shorter distance. At that time the sun has to travel shorter distance as compared to the horizon. So as the sun has to compare the shorter distance, the sun appears white because only the little of blue and violet color are scattered, right children? So this is it. And this is one more important question, that is when the astronaut is in the space, to him the sky appears to be dark. Why? Because children, in space there are no scatterers, there are no scattering particles, there are no dust particles, there are no gas particles, there are no water particles. So no scatterers means no scattering. No scattering means the light is not going to reach your eye, and if the scattered light does not reach your eye, you are not able to see anything. You will see dark, right? So for this reason, the sun would appear dark to astronaut, because scattering is not prominent at such high altitude due to the absence of the scattering particles.